All right. Technology. All right. Stop. So I want to remind you that for American men, the mean height is 69 inches. The standard deviation, if I remember correctly, I think he used 2.5 lines. Let's use the real thing. I think it's 2.8 inches for standard deviation. So I'm pretty much 5'9", so I'm right on the mean. Right. So, what do I need to know in order to use the chart? I mean, what is the name of the chart? That is the what chart? Z-score chart. So what do I need to know before I can use it? Z-scores. It's crazy. So some of the problems are going to have Z-scores, and I can just look it right up on the chart. Some of the problems are going to be like this. Men's heights are normed to be normal. So I know I can use the Z-score chart, and that's another thing. You can't use the Z-score chart unless it's normal. If it's not normal, who the hell knows how much area is where? Then I can use Chubby Dude, or Chevy Chase, or however you want to call it. So what if I ask you, what's probably that some dude is taller than 74 inches? Right, which for us would be 6'2". So probably somebody's taller than 6'2". So a good first step is draw the picture. So I'm going to show you what I highly suggest you do. And then, of course, as always, you can do whatever you want to. But I highly suggest draw the picture with the what I call raw scores. These are the raw scores. We call it raw because we haven't processed it yet. When I throw it into the Z-score formula machine, I process it, and then it chunks out Z-scores out. So that'll be the processed number, you guys. So that's why I call these raw scores. It's going to come up sometimes. I just want you to be ready for that. What goes right in the middle of this picture? No? There you go, 69. The mean is 69. Now, underneath that, I'm going to put in parentheses 0. When I learned this, my teacher made us draw two separate pictures, and I'm like, but dude, it's the same picture. Do it. All right, sure. So I did.
He was French?
Yes, in my memory he was. He was actually not, he was so American, it's crazy. And he would mumble, so maybe it just sounded French. And he always had his coffee, and that's why I got it. Yeah, sorry, Mr. Pearson, wherever we go. Where's 69? I'm sorry, the question is about 74. Where's that? Above it. So just plunk it somewhere, it doesn't matter. And then the question now, shade in the area that the question wants. Where's the area the question wants?
Above.
Above. Alright, cool. So the only thing I have to do to make it more like the problems we already did is to take that number 74 and do what with it?
Subtract it from 69.
Well, that's the first step in doing what? Making it into a
Z-score.
Z-score. What's the Z-score formula? Oh, shit. I don't know, Jeff, we haven't done that in a while. I know. Well, like you said, the first step is how far apart are x and the mean, because the Z-score tells you how far apart they are. In what? How many whats?
Oh, standard deviation.
Yes, so divided by the standard deviation. So take a second and change 74 into a Z-score. Did Milad come in, Tilko?
And is it 4 decimal places that you round to on the Z-score?
3. But no. What do you think with the chart we're using? It goes out how many places?
2.
2. There you go. So z is 74. That's my point that I'm interested in, minus the mean, divided by 2.8. What do you guys get?
1.79.
1.79, truly rounding, right? So it's like 1.785, so then you round it to 1.79, is that cool? All right. I'm crowdsourcing that, so it sounds good. And now it's exactly like the problem we did. So the very first thing we do is we take the raw score and we change it into a z-score. Now if I already have a z-score, then I don't have to do that step. And once I got a z-score, I look it up and then get the percentage. So that's kind of the process. If I have this, I make it into this, and I look it up in the chart. If I have that, I look it up in the chart. Because I don't have to change it. It's already a z-score. So let's see, when you look that up, 1.79, 1.7. Good, 9633. So, what does that mean physically? Where is that on the picture?
Going left, away from 74.
Good, because the chart always tells me. And why does it make sense? If you draw it going this way, you're telling me that 96% of this is there. Doesn't make visual sense, right? So that's another thing the picture does for us. And that's why it always kills me when people put the 74 down here. They can't see that they made a mistake. Because to them it looks fine. Put it in the right place and it's another check. So what does that number by itself mean physically?
That 96% is underneath 74.
And be more physical.
So 90% of men are less.
Yeah, so a little more than 96% of men
are shorter than
shorter than 74, shorter than 6'2". I like it. I like it. And the nice thing, I want you to realize, this is not made up shit. This is true. This is true, period. Because I know the mean, I know the standard deviation, I know it's normally distributed. In fact, it's kind of defined to be something that should be normal. It's a biological thing. It's the height of an animal. So it should be normally distributed. And it is. It totally is. It's kind of nice. Or close enough for us. So what's the actual answer then?
0.037.
Yeah, real quick. I don't know if you guys ever, I know the calculators do this, but a real quick way to do 1 minus a decimal is make everything 9. What makes 9 0? What makes 9 9? 0. What makes 6 9? 3. What makes 3 9? And then make the last one 10. I don't know if you guys ever saw it. It's a little trick. And you're like, all right, that's nice. My trick is this. All right. I'm okay with that. So what does that mean physically? The opposite of what we just said. Almost 4%, or a little under 4% of men
Are taller than 6 foot.
are taller than that. So if I made my door 74 inches tall, this percentage of men would be expected to have to duck to get through it. So you'd have to expect this percentage of the men would be complaining to you possibly, right? So if you want to control the number of complaints you might get for people hitting their head on the door jamb, you change the height of your door a bit so you have less percentage, less probability of people doing that. Are you guys with me? I mean, this is an immediate practical application. How wide do you want your airplane seats? And we start talking about that a little bit, so we can do the average hip breadth of Americans. And of course, we know that it kind of went out a little bit further. So they actually did change the size of the airplane seats, or on some airlines.
How'd you get 0.0367?
Oh, 1 minus this.
Okay.
So it's that old idea that the opposite probability of something is 1 minus that probability of God. So 1 minus this probability is the opposite probability, the opposite side. And it's also because the whole thing is 1.
I put it in wrong, that's fine.
Oh, okay. How are we doing with that? Is that decent? All right. With that said, well, I almost forgot what the actual next thing is. So what I was talking about is number 4. We'll do that in a minute. But look at part D. What is it that I do not know in part D? Where are you? There you are. What do I not know? Oh, and you're like, Jeff, I don't know what you don't know. That's what I don't know. We don't know the z-score. It's asking me for the z-score, so I don't know the z-score. So 0.33 is not a z-score. What does P33 mean?
The 33rd percentile.
33rd percentile, or the position that has what percentage where. If you're in the 33rd percentile on a test, are you happy? No, because you only scored higher than 33%. So where on the picture would that go? If I put it here, that doesn't make any sense because how much is below that? 50%. That's the mean. It cuts it in half. So where should it go? Down here. It should be down here. And this, how much is that area? How much area is that? You know exactly. 33. So 0.33. Let me stop there for a second.
So what do we put in the middle?
Second.
What do we put in the middle?
Oh, the middle's the mean. So I was just trying to show you guys why it made sense to put this over there. Because if it was here, that's 50% below. That's P50. That's the median. So it's got to be here to have 33%, right? If it was P80, it would have been up here. With me? Visually, if I said P80, that should be the line that I draw that has 80% below it. So that's 50%, so it'd have to be up here, so now it's got 80% below it. I like it. I like that expression. Is one of my favorites. All right. Just right. And I don't do this, but I don't know if there's anything about P90X. Is that the name of that?
Yeah.
Every time I say P33, P80,
Work out
it's a new P90 thing. So what I have to do now is the exact reverse of this. I know the percentage. So math always works both ways, right? So if I can look up a z-score to find a percentage, I can look up a percentage to find the z-score. But how the hell does that work, Jeff, man? I just got this damn thing here. You're doing this shit. Well, which side do you want to look at, negative or positive z? It's got to be negative because it's below the mean. And I've got an area, so I'm not going to do this. I'm not going to look at 0.33. That would be a z-score. Where's the areas? In here. These are the areas, right? So find 0.33 in here. There it is. And of course, it's like related to the one we did earlier, right? Negative 0.44. Kick ass. Do you guys see that? No, Jeff, you don't have it. So you got it. This is what I meant earlier when I said you got to tell yourself, do I have a z-score right now or do I have an area right now? Because it's going to totally change what you do. If you have a z-score, you look on the outside. If you have an area, you look on the inside. And then you look out to see the z-score. So my z-score for this problem is negative 0.44. I'm done. I found the z-score for P33. I'm done. Negative 0.44 has 33% below it. I think I did that so I can point back here. See? This is when we did the other way. We got 33% below it. Maybe. Maybe. Okay. So you guys try part E. And the sentence pretty much tells you exactly how to draw it. And you got to remember that the chart only understands the areas that are where. Areas that are where? The chart tells me areas that are below the z-score. Alright? So it should help you with that. Let's find out. This should have an asterisk where you're looking, and just follow it. If you're not sure what I mean, you haven't found it yet on the chart. You'll see what I mean. All right. So where on the picture should it go?
Just
Yeah, up here. So it has a very small percentage above it. So this would be, that's just 0.05 of the pictures in there. My chart wouldn't understand that at all. If you look it up, you're going to get the negative. You can use a shortcut, just take the negative off. If you don't know what I just said, do it this way instead. The chart only understands the areas that are below. So if I got 5% above, how much do I have below?
95%.
Good, 0.95, 95% to gas. That's an area, so then I look to find the z-score. I look that bad boy up, and the closest I can get to 95% is actually right in between these two. So watch, this one would be 1.64, and this one would be 1.65. So if you follow the asterisk, not surprisingly, it's 1.645, right in the middle. Why? Because it's right in the middle. Maybe. So again, if I know an area, I look it up in here. The area is 95%, so 95% is right in between those two. You guys kind of with me? Now normally, if it's not right in between, you just take the one that's closest. But this is right in between, you follow the last is 1.645, right in between 1.64 and 1.65. So this will be 1.645. Maybe. So now, you should know enough to do these. And unfortunately, this is not real data. I don't know what it's like nowadays to park. I mean, it depends on what time I get here. Sometimes it takes me 15 minutes to find a spot, even for faculty. So, what's it like for you guys? This is for a whole week. 31.64 minutes per week. So maybe like 6 minutes a day. Does it take like 6 minutes to find a spot or more? Huh? 3 minutes? Oh, that's good. What the hell? Nobody should be complaining then, shit. At my university, they sold 2.5 tickets for every spot that there was.
Depends on what time you come, that's all.
Yeah, totally. If you're here early like me, then hey, spots all over the damn place.
So, like, when we were talking less than 27.2, can't we just use the little I call it the alligator, but the less than or greater than sign? Wouldn't that tell us the direction we're looking for?
Yeah, exactly. Just like when you graphed inequalities, x less than 2, the less than sign tells you which way to shade.
Yeah.
Same thing. Tells you which way to shade. So please, you can work with people near you. You can call me over if you need help. I wanted to devote all of today to this because this is going to be a part of almost everything we do after today. So if you don't like it, it can be everywhere after this. Yes, the mean is there, less than that, so you can shade below. So before you can find the area, the probability, what you have to do is 27 points. It's going to be a lot like that problem we did with the heights. You have to change it into that z-score formula, the x minus the mean. You have to change it into a z-score, so then you can use this chart. As soon as you get one made, well, yeah, normally I think I'm going to talk to you guys in classes. Normally people don't like to see it. Just that when I get the emails and grade and stuff, and I'll get back to it as soon as you get graded. Yeah. Good. Yeah, let me do it.
I can go up there too.
All right. Won't say no to that. Anybody else not get their double quiz back? Myra, Anthony. Okay.
No, it's always x minus the mean. The mean is always second. It should come out negative because this is below that. Minus that. And whatever that is, divide by.
What was that?
They were here. Yes, cool. And then you just look it up. And the nice thing is it's less than, so once you get the z-score look up, you're done with that problem. And once you make it into a z-score, and you look it up, you're done. So, what's in the middle? All of these. Only 0 fits the z-score, so these aren't z-scores yet, so in the middle goes to the mean. And then you put 27.2 in the right place. Then you change it into a z-score using that formula, the z-score formula. Right? So you get x minus mean instead of
I have a question. Am I doing this right?
So put that on the picture, make it into a z-score, and then look it up.
So for the first one, I was wondering if what I did was right. Because see, this 27.2 is going to be below the mean, right? So it'd be negative 27.2.
Well, no, it's 27.2. The z-score will be negative.
The z-score would be negative, so I put it here and I got a negative 0.57.
Then you
I would
look it
just
up.
take that, and this is pointing me to the right, so it's looking for the area to
The
the
area
left.
below, so it's exactly what the chart tells
Okay.
you. You're done.
So easy peasy.
This one will be
This is
extra on, yeah.
1 minus that.
You.
So, do we need to?
No, it's 27.2 minutes. You use that
Did you
formula to
because
make
my
it into a
mentorship's
z-score.
horrible, so I can kind of explain. Are you still on
The
this
z-score
one?
tells you how far data point is.
What are
away
you
from the
having trouble with?
standard deviation. So
So you've got-
convert that. I know it's below. I know it's going to come out negative, which is less than the mean.
Okay, so you have.
But that tells me exactly
you have
how many steps away it is.
27.2, right? And it's looking for x like
27.2
less
minus
than
that.
27.2. So
Divided
it's looking
by-
for, so what is the probability that it will be less than 27 minutes? And so we're looking for this area essentially. And what I was talking about when I was asking the question, you see where that arrow is pointing?
And then if you
Like
look
the
that up,
sign, it's pointing to the left. So when you
That's
do
just
less
the
than,
z-score,
it's
right?
looking for the area to the left.
negative
So
0.57.
what you need to do on this next step is you need to
-0.5.
convert this into a z-score.
7.
And how do you, and you use the formula z equals x minus mu over the standard deviation. So since you already have the mu and you already have the standard deviation and you already know x is what you're looking for, so you do 27.2. You do 27.2 minus 31.64 divided by 7.81, and you would get the answer you get for that would be negative 0.57. Then you would just go to the z chart and then just look for that area that's represented. No worries.
Where are we at, sir? No. 0.5.
Oh.
And then it should be, what do you get? Because you have negative 0.5 for the z-score. 0.57, yeah. Oh, that's what it is? Okay, good. So look at negative 0.57.
It's supposed to be more than, right?
More than, yeah, exactly.
should be a small, so you look it up, and then 1 minus, that's the right idea. I don't know if that's the right number yet. Okay, I'll just do those.
And then
Save
you're
you some
an
work.
area of what you're
20, 25, 7, 843. And the question was less than, so I don't have to do 1 minus. The chart tells me less than. So for anything, if I want to use that chart, I have to use that formula. It's not already Z-scores. So I didn't have to use it up here because they were already Z-scores. If they're not Z-scores, I have to use it.
Oh, I thought you did that after you. So X is what you're trying to do.
That's the Z-score. Look it up around different places and then look it up. Find the area below it, which is actually 2 places because this only goes up 2 places. 0.57, negative. And then you look it up to get the area below it.
Yeah.
Do you have 42877?
Yeah.
Okay.
Alright, so here's the first one. Walking around, most of you guys are getting there. You gotta be real careful though. Sometimes people will stop when they get the Z-score, again, because Z-scores look like areas. You're like, oh, 57%, I'm done. But that's a Z-score. You don't have the probability yet. So if you look up negative 0.57, like many of you guys did, you'll get 0.2843, right? So that means there's a little more than a 28% chance that a randomly selected student in Parson campus will take less than 27.2 minutes a week to find a spot. Because a huge part of statistics is being able to interpret what the hell you just did. Getting the number is not good enough. Understanding what it means is more important, actually, in a way.
Only 28% of the people take less than 27.
Exactly. So those are the lucky ones, right? Number 2 would be the really unlucky ones. When you do this work, when you do this homework, make it really clear to me what the answer is. circle it. Right.
I prefer boxes.
Boxes is awesome. Boxing, you can trapezoid it.
Star it.
You can rhombus it. Sounds like a weird way to do your waiter job. Rhombus that thing. When you look up 2.73 on the second part, is that what you guys got for the z-score for the second one?
Yep.
All right, thank God. I did it right. When you look it up, you're going to get the area that's below that. 2.73 gives you what area?
9968.
Yeah, 9968. I like it. 2.73, 9968 is down there. So how much is up here? 0032. So there's like a 0.32% chance that somebody would take more than 53 minutes to find their spot. So it's not impossible, but it's really unlikely. All right, cool. I like it. And then this guy, this is the one everybody tries to make the other ones into. This is when you finally find two areas and subtract them, right? So the middle is still 31.64. So all the action for this one is happening down there, 15.5, 19.5. I want that area. So I want to convert each of these into a z-score. So the smaller one looks like that, and you get whatever. 2.07. And then the other one, yeah, there's 7.81. 1.57? Is that, I don't hear any. Oh, 5.5? All right, there you go. Just repeat it back wrong, and then I get more people saying. So I just need to find the area between those two. So I first got to find the area below those two, and then I can subtract them. So below that one, negative 1.55 z-score, I get
0.0606.
0606, kick ass. And then below the one that's negative 2.07, 0192. That's always useful, Jeff. Kick ass. And then you just gotta subtract those. So 0.0606 minus 0.0192 gives you what now?
0.0414.
Whew. So about a 4% chance almost. Thanks. About a 4% chance that it would take between those two that many minutes. Maybe. Yes, ma'am.
Do you want them written in percentages, or can we?
Well, I'm just doing this. See how I circled that one?
Yeah.
That's what I want.
Okay.
You can kind of approximate it and make it more human. Because you wouldn't say there's a 0.041. No, you'd say about 4%. Just talking to somebody. But I need to see the answer. That's what I primarily am looking for. I'm not making you guys see so. So what about, anybody try this one yet? Maybe. Well.
Do you just plug it into the equation and?
So what we've been doing on the first three problems was this. They gave us an X score, we made it into a Z score, looked up the percentage. This one is the 14th percentile, so we're starting here. So
That'd be 0.14.
so where's that going to go?
All the way to the left.
So this will be, this area is 0.14. Do not put 0.14 below it. Let me make a big deal out of that. I don't know if you guys picked up on this. Areas are always up here. Areas are always up above. Z-scores are always down below. Again, because they're evil. They look like each other. Right?
Wait, so 14th percentile?
Yes?
That's, you're talking about the area and you're just saying 14% of that?
Yep.
Something?
Well, area and percentage are the same thing when I have a picture of a distribution. So 14% of the area, that picture is down there. So the probability that I got somebody in there would be 14%.
Okay.
So from this, we've done this earlier, I can figure out what the z-score is from this. But the question is, what's the time? It is not time to get ill. I'm sorry. Not really. I couldn't stop myself. So that's an area, right? So where do I look that up?
In the negative.
Good. So the negative in the body. So 0.14, the closest I can get. Oh, I get pretty close, yeah. I get 1401 there. That's the closest I can get to 14%. Is that? Do you guys see that? Right, I like that 1492. Columbus Revolution. Negative 1.0. I'm getting sick looking at that. Negative 1.08. Good. Whoever said that, you're right. So that's negative 1.08. Now, if you just stop there, Jeff, can you make a 8? 1.08. There you go. Good job.
Put in negative 0.98. Not 1.98.
Negative 1.08. Let me do this again. So here's 14. It's negative 1 point. See there? Negative 1.08. So there you
easy.
go. It's so easy. I understand that. That's the part I definitely understand.
That's all right.
Now, how do I get... I need the time. I've got a z-score. I've got a z-score. Sorry, can't do Christopher. Yes?
You plug it into the equation.
Yes, you do. And we're going to make a better equation real quick. You can. We're going to just rewrite it in a better way. So you can have this sitting on your formula sheet. And the really nice thing is, what do you wish you could write on your formula sheet that I'm evil enough that I say you can't? You wish you could write notes. The formula I'm about to tell you is a note. Let me see if you guys actually... I can read it in English and it tells me something. Because I don't think I've said this yet, but on every test from here on out, I'm going to ask you the same question. What does a z-score tell you? I'm going to ask you that. Someday I'll get everybody to get that right. Hasn't happened yet. Right, but I've told you exactly what it is, and I told you it's going to be on the test. Right? So now watch this. How do I solve this? This is good if I know these things and I want to know that. But what if I know this, and I know this and this, and I want to know that? Well, how do you solve for this?
Use algebra to isolate.
No way. All right. And then what? So more specifically, what do I do? Yeah, multiply that up, because that's the worst part of it. And then I add the mean. So I get x equals mu plus z sigma. So what's the standard deviation? It's the number, what's the z-score? It's the number of these. I go from this to get to there. So if I start the mean and I go this many standard deviations, I get to the data point. That is the answer to the question that I will ask you on every test. So if you have your formula sheet, you'll have the answer staring you in the face. And I'll still be able to. So just getting the words in there are not good enough. You have to get the idea. Right? And so how can I use that now? Well, we got the z-score is negative 1.08, right? So I know the z. What's the mean?
31.64.
31.64 plus, plus negative 1.08 times, the standard deviation was 7.81. So throw that in the calculator. 23.21 minutes. Cool. So that would be the dividing point. That person would be in the 14th percentile. And of course, in this situation, the lower percentile is better. Sort of like golf, right? Because it means it took you less time to find a spot.
But we have to put the minutes down, or you don't mark us down, right? If we do that.
Units are important, yeah.
Units.
So that's the bare minimum of showing me that you understand what the hell you just did. Right? There's units. I like it. This is perfect because I needed to leave a little early, and that's all I wanted to do today.
Can you go back up to the...
Don't forget this.
Can you just go back up to the third one on number 4, please?